In this video here, we're going to take a look at exam revision for roots of polynomials. So as you can see then, this will cover the following topics here. So we have roots of a quadratic equation, roots of a cubic equation, roots of a quartic equation, expressions relating to the roots of a polynomial, and then finally here, linear transformations of roots. Now, as always, what I'd recommend here is that you pause the video and have a go at the questions as they appear, and then just double check that your solution matches what we get on the screen. So that should give us everything that we need here to get started. Let's begin now with question 1. So let's just make a start then with question 1 here. So as we can see then for question 1 here, we're told that the roots of the following cubic equation here, alpha, beta, and gamma. Now for the first part of the question, part A, we're then given that alpha, beta, gamma is equal to 2. And all we want to do here then is just write down the value of A. So to get us started here then with part A, let's just quickly make a note then that alpha, beta, gamma, you should be aware here then that alpha, beta, gamma is equal to minus D over A. But alpha, beta, gamma here, as we're told in part A, is equal to 2. Okay, so going back to the cubic equation here, well, A, we don't know what that is, right? So let's put a question mark there. B is 2. C is 3. And then finally D here is minus 4. Okay, so putting this all together here then, what I've got is minus D over A is equal to 2. I've got minus then D here, which is minus 4, over A, which we don't know what that is, right? So let's put A there, like so. And this here then is equal to 2. Okay, so let's just divide both sides here by minus 1, right? Get rid of the minus here on the left-hand side. I think at minus 4 over A is equal to minus 2. So as I get rid of the minus here on the left-hand side, right, we still get a minus here. Once I get rid of this minus outside the bracket, but it doesn't matter too much, right? Let's just times through by A here. If we do that then, get minus 2A is equal to minus 4. And then finally here, right, just divide both sides by minus 2. We find that A is equal to 2 there. Okay, so nice and straightforward there. That gives us the solution to part A. Now for the second part of the question here, this is part B. All we want to do here then is find sigma alpha and sigma alpha beta. So this here then is our alternative notation. So for sigma alpha here, you need to be aware then that this is equal to minus B over A. Okay, so nice and straightforward here then. If sigma alpha is equal to minus B over A, that is equal to get minus 2, because B is equal to 2, and A here is also equal to 2. So get minus 2 over 2, which just simplifies to give us minus 1 there. Okay, so that's sigma alpha. What about sigma alpha beta here? So sigma alpha beta is equal to, so you need to be aware here that this is equal to C over A. Okay, where C here then is 3 and A is 2. So I just simply get there 3 over 2. Okay, and that gives us the solution to part B. And then finally for the very last part of this question here, part C, as we can see, right, split into 2 different parts. So for C part 1 here, what we want to do then is find the value of 4 over alpha plus 4 over beta plus 4 over gamma. So 4 over alpha plus 4 over beta plus 4 over gamma. Okay, well, the first thing that I can do here then is factor out the 4, right? So this here then is 4 times by, get 1 over alpha plus 1 over beta plus 1 over gamma. Okay, and 1 over alpha plus 1 over beta plus 1 over gamma, well, using our alternative notation here then, this is equal to 4 lots of, so what I get here then is sigma alpha beta for my numerator, and then for my denominator here, we get alpha beta gamma. Okay, this expression here is 1 over alpha plus 1 over beta plus 1 over gamma. So we know the value of sigma alpha beta here. that is 3 over 2. We know the value of alpha, beta, gamma. It was given that in part A, right? So let's just put all of this here together. So what I get here then is 4 lots of the sigma alpha beta, that is 3 over 2. So you get 4 lots of 3 over 2 all over then alpha beta gamma, which is equal to 2. Okay, like so. And if we just simplify this here then, 3 over 2 divided by 2, that's just the same as 3 over 2 times by a half, which is 3 over 4. So you get 4 lots of 3 over 4 here. Obviously, what will happen here then is the 4's will just cancel, and we just get left with 3 then. Okay, so the solution to C part 1 is 3. And now for the second part here then of part C, this is part 2. What have we got here then? We've got alpha squared plus beta squared plus gamma squared. So alpha squared plus beta squared plus gamma squared. Okay. And again, just by using our alternative notation here then, you should be able to see that this is equal to, so this is sigma alpha all squared minus then 2 lots of sigma alpha beta. Okay, so sigma alpha then, that is minus 1. So what I get here is minus 1 all squared minus 2 lots of sigma alpha beta, which is 3 over 2. So minus 2 lots of 3 over 2. Okay. If we evaluate this here then, minus 1 squared is 1. The 2's here will just cancel, right? So what I get here then is 1 minus 3, which just simplifies to give us minus 2 there. And in that case, then the value here of alpha squared plus beta squared plus gamma squared is equal to minus 2 there. Okay. And there we have it then. So hopefully nice and straightforward there, just to get us started. That gives us the solution to question 1. And now for the very last question of this video here, question 2. As we can see, then we're given this quadratic equation here, right, which has roots alpha, beta, gamma, and delta. We're then given 2 of the roots here. So I've got gamma is equal to 3 plus I, and delta is equal to the conjugate then of gamma here. So these 2 roots, right, occur in a complex conjugate pair. Now for the first part of this question, part A, what we want to show then is that alpha plus beta minus 4 is equal to 0, and alpha beta minus 3 is equal to 0. Okay, so for part A then, let's just make a note here then that gamma is equal to 3 plus I. And then for delta here, delta is equal to 3 minus I. Okay. Now, what I know here then is that alpha plus beta plus gamma plus delta, this here is equal to minus b over a. Okay. And also, let's just quickly note here that a is equal to 1, b is equal to minus 10, c, well, we don't know what that is, right? Same again here for d. And then finally for e here, that is equal to 30. Okay. So alpha plus beta plus gamma plus delta is equal to minus b over a. Well, we know what gamma is, and we also know what delta is. So what I know here is that alpha plus beta plus gamma, which is 3 plus I. So plus 3 plus I plus delta, which is 3 minus I. So plus 3 minus I there. And this here then, this sum of the roots here is equal to minus b over a. So that's minus. So minus minus 10 over a, which is 1. Okay. Well, minus 10 over 1 is minus 10. Minus minus 10 is 10 there. Okay. So let's just simplify here then. So I've got alpha plus beta. I've got 3 plus 3. So that's 6 there. The i's here just cancel, right? So they just cancel. So I've got alpha plus beta plus 6 is equal to 10. And then if we just subtract 10 here off both sides, right? We obtain alpha plus beta, 6 minus 10 is minus 4, and all of this here is equal to 0. Okay, so notice here then, this is exactly what we wanted here. So as required, perfect. And let's also just derive this equation here, right? So alpha beta minus 3 is equal to 0. So what we know here then is that alpha, beta, gamma, delta is equal to E over A. Okay? So I've got alpha beta times by gamma delta here, where gamma is 3 plus I and delta is 3 minus I. Okay, so I've got 3 plus I times 3 minus I. Like so. And this here then is equal to E over A. So E here is 30 all over A, which is 1. Okay, like so. So let's just expand here these double brackets. Right now, these double brackets here is just simply the difference of 2 squares. So it's just basically going to be 3 times 3, which is 9. I times minus I, which is minus I squared, which is equal to 1. So what I get here then is alpha beta times 9 plus 1, which is 10. So I get 10. Alpha beta is equal to 30. Let's just divide both sides by 10 here. So alpha beta is equal to 3. And then finally here, if we just subtract 3 off both sides, then what we get here is alpha beta minus 3 is equal to 0, exactly as we wanted here, right? So again, as required. So perfect, there we have it. That is the solution to part A. And now for the final part of the question here, part B, it just says, hence find all the roots of the quartic equation and find the values of C and D. So for part B then, how do we do this? Well, what we know here in part A, right, is that alpha plus beta minus 4 is equal to 0, and also alpha beta minus 3 is equal to 0. So what I've got here then in part A is simultaneous equations. So all we want to do here then is just solve these simultaneous equations for alpha and beta, right? Because alpha and beta here are the 2 remaining roots. So starting off then, what I'm going to do here is rearrange this equation, making alpha the subject. So if I do that here then, I get alpha is equal to 4 minus beta. Okay? And all I'm going to do here then is just substitute this into this equation here. So if I do that here then, we get, I'll do the beta on the outside actually. So beta times 4 minus beta minus 3 is equal to 0. So let's just expand here. So I get 4 beta, and I also get minus beta times beta, so minus beta squared. So minus beta squared plus 4 beta minus 3 is equal to 0. Okay, let's just take everything over to the other side here, making the beta squared positive. So if I do that here then, what I get is beta squared minus 4 beta plus 3 is equal to 0. Okay? So what I want to do here is solve for beta, right? And hopefully this will factorize. If it doesn't, we need to employ a different method such as the quadratic formula. But the good news here is that this quadratic equation does factorize. Okay? So what I get here then is beta minus 3 and also beta minus 1. Okay? And all of this here then is equal to 0. So what I get here is 2 solutions, right? I get beta is equal to 3, and also beta here is equal to 1. And what I also need here then is the respective solution for alpha. So what we had here then is alpha is equal to 4 minus beta. So if beta is equal to 3, then in that case, alpha is equal to 4 minus 3, giving us 1. And then if beta is equal to 1, alpha is equal to 4 minus 1, giving us alpha is equal to 3. Okay? So in that case then, what we can say here is the roots are given as, so the roots are, so I get 1, 3, so 1, 3, and we also get the two roots here given in the beginning of the question, right? So 3 plus I and 3 minus I. So 3 plus I and also 3 minus I there, okay? But we're not finished here because what we also need to do then is find the values of C and D. So how do we do that? Well, we're going to use our standard results here. So we know then that sigma alpha beta here, this is equal to C over A, okay? Now, obviously, we don't know what C is, right? That's what we're looking to solve for. But we do know the value of A. And we can also obtain here sigma alpha beta, okay? Because we know the four roots here, 1, 3, 3 plus I, and 3 minus I. So what I get here then is, so obviously I don't know what C is, but I do know that A is 1. So in that case then, sigma alpha beta here is equal to C, okay? Now sigma alpha beta here is equal to the following. So therefore C is equal to, so I get alpha beta. So alpha beta plus alpha gamma plus alpha delta plus beta gamma. So beta gamma, oops. It's kind of like an in-between of delta and gamma. Let's just try that again. So too many Greek letters here. So beta, gamma, there we go. What else do we have here? So I'm also going to get beta delta. So beta delta. And then finally here, gamma delta. Okay, so gamma delta. So I know the four roots here. So in that case, then C is equal to, so alpha beta is 1 times 3. So 1 times 3 plus alpha gamma here. So that's 1 lot of 3 plus I. 3 plus I plus alpha delta. So that's 1 lot of 3 minus I. Beta gamma. So that is 3 lots of 3 plus I. Beta delta. So that's 3 lots of 3 minus I. And then finally here we have gamma delta. So that is 3 plus I times 3 minus I. So 3 plus I times by 3 minus I. Okay. And at this point here then we can now evaluate C, right? Let's just basically expand and simplify here. So in that case then C here is equal to 1 times 3. So that's 3. 1 times 3 plus I. So we get 3 plus I. I've got 1 times 3 minus I. So again I get 3. When I get minus I won't cancel anything just yet. I'll do that at the very end. I've got 3 times 3 plus I. So we get 9 plus 3i. I've got 3 times 3 minus I. So we're going to get 9. And we get minus 3i. And then finally, for the final products here, this is just the difference of 2 squares, right? So again, I get 9 plus 1 here, giving us 10. Okay. So let's just basically cancel here and simplify. So the i's here cancel. Same again here with the 3i and the minus 3i. So let's just simplify here. So 3 plus 3 plus 3 is 9. Plus another 9 is 18. Plus another 9 is 27. Plus the 10 here, that gives us 37. So then in that case, the value of C here is 37. So C is equal to 37. So to finish with here then, all we now need to do is find the value of D. So pretty close to the final solution here. So for D then, we're going to make use of the fact that alpha, beta, gamma here. So alpha, beta, gamma is equal to minus D over A. Okay. Now, we don't know the value of D, right? That's what we want to solve for here. I do know the value of A. So again, A here is 1. So what I get here then is minus D over 1, which is just minus D. That's just equal to minus D. So in that case then, what I've got here is minus D is equal to, so I get alpha, beta, gamma. So alpha, beta, gamma. I also get alpha, beta, delta. So alpha, beta, delta. I also get alpha, gamma, delta. So alpha, gamma, delta. And then finally, we also get beta, gamma, delta. So beta, gamma, delta there. Okay. So let's just evaluate this here then. Again, it's going to be pretty similar to part C, right? Or not part C, when we were evaluating C there. Too many letters, too many Greek letters. But we're nearly there with the solution. So let's just keep going here. So alpha, beta, gamma then. What would that be? So that's going to be 1 times beta, which is 3, times by gamma here, which is 3 plus I. So I get 3 times 3 plus I. Like so. I've got alpha, beta times delta. So again, this is 3 lots of delta here, which is 3 minus I. So 3 lots of 3 minus I there. I've got alpha times gamma delta here. That's just going to be 1 lot of this here. So plus 3 plus I times 3 minus I. And then finally, we get 3 lots of this again. So 3 lots of 3 plus I times 3 minus I. Okay. So to finish with here then, let's just expand and simplify. As you can see, right, I don't have a whole lot of room here. So let me just do the simplification above here. So 3 lots of 3 plus I, that is 9 plus 3i. So I get 9 plus 3i. Again, I get 9 minus 3i here. So 9 minus 3i. This here is a difference of 2 squares, right? And I just get 10 here. So plus 10. And here I get 3 lots of 10, right? So just get 30 there. Like so. So this 3i here, and this minus 3i just cancel. So I've got 9 plus 9, that's 18. And plus the 10 here, that gives me 28. And then plus another 30 here, and that just gives us 58 here. Okay. Now just be very, very careful. So this here is minus d is equal to 58. So what we now need to do here is just divide both sides by minus 1. And as we can see, then d here is equal to minus 58. Now just make a note here as well, right? D then is equal to minus 58. And there we have it, bosh. Nice and easy. I say nice and easy. As you can see, certainly quite a long question, right, to get to the final solution here for part B. And it is very, very easy to make any kind of small mistake here as you work through questions like this. So just take your time. Just be very, very careful as you go through questions such as this one. But there we have it then. So that gives us the solution here to the very last question, question 2. And that brings us to the end then of this video here on exam revision for roots of polynomials.